So you are given y, t squared, t plus 1. Differentiate this. You are differentiate y with respect to t. Look at your t. Where's your position of your t? Dekat atas ada, dekat bawah ada. So, quotient rule. Jangan angkat dia nak pergi jadi buatkan dia how a product rule. After you buat product rule, you kena turunkan balik jadi pecahan yang cantik. So, you akan sangkut kat situ, pecahan kamu tak dapat. Kalau you dah atas ada, bawah ada quotient rule lah. What's your quotient rule? V U prime U V prime over V square, right? Okay, so I will do it directly. Salin yang bawah, differentiate yang atas, tolak. Minus, quotient rule is minus. You buat tambah salah semua. Nampak? Salin yang bawah, differentiate yang atas, salin yang atas, differentiate yang bawah, bawah square sama dengan V U prime U V prime V square. So, differentiate yang atas, 2t, differentiate yang bawah, 1. Simplify this. Expand 2t square plus 2t minus t square over t plus 1 square. So, t square plus 2t over t plus 1 square now. Stop here. So, make sure you write dy dt. You differentiate y respect to t. You are not respect to x. So, for x part, differentiate x respect to t. Look at your t. What's your position of the t? Is it quotient rule? No. This one, it will be more easier. We take out it as power rule. Okay, so what's the power rule? Differentiate x with respect to t. Power rule. Power turun depan. Power tolak 1. Differentiate dalam kurungan t 1. Then negative 1 over t plus 1 square. So, adakah kita nak dx dt? In parametric, dy dx is obtained by using formula dy dt dx. In second derivative, also differentiate respect to t for dy dx times dt dx. So, what we need here is not dx dt, we need dt dx. Inverse it. Terbalikkan dia. Then only this dy dt dx dt is ready to help you to find dy dx. Alright, so for the first part, dy dx first. Substitute our dy dt. Times dt dx. Then what can you see? Cancel for the factor of t plus 1 square. And then your dy dx only is t square plus 2t. So our purpose is until second derivative. Second derivative, if you differentiate again, is not d2y dx squared. When we differentiate again, we are just differentiate this dy dx with respect to t. Negative, yes. Alright, so don't write it as d2y dx squared when you differentiate again, because it is respect to t, it's not respect to x. Then, when you really want d2y dx squared, it will be this differentiation times dt dx. You always remember, for parametry, at the end there, times dt dx, times dt dx, takkan salah. Kalau you just differentiate saja, memang akan salah. So how we do this? Negative, negative, we get positive. 2, I factorize out. Alright, then look at the questions. Evaluate means menilaikan. Cari nilai di mana point dia 1/2, 1/2. So kita belum menilai lagi. Sekarang adalah masa kita menilaikan. Find the value. Do you have t value? So our main purpose here is obtain t value. Once you obtain your t value, then you can know what's the value of t2y dx squared. But the question given here is not t value, it's x value and y value. So the question also given x equation, y equation. So when x is 1/2 and when y is 1/2, we find out what is your t value. So this is your x. So itulah kegunaan dia kenapa soalan bagi kamu koordinat. Supaya daripada x nilai dengan y nilai tu cari balik nilai t. Barulah boleh menjawab parametric second derivative ni. Okay, simplify this inverse t plus 1 equals to 2. So t equals to 1. So this one cross multiply 2t squared equals to t plus 1 quadratic. So quadratic, don't forget your factorize to get your t. Negative 1/2 and 1. So what is the parametric that can hold for x and y? When your x parameter just 1, or when your x having parameter value t1, when your y having parameter t equals to negative 1/2 and 1. So what is your parameter in these questions? Just only 1. So therefore, we substitute t equals to 1 into d2y dx squared. Kalaulah soalan, when x equals to 1/2, the parameter is 1 and negative 1/2. Y pun jawapan yang sama, negative 1/2 and y. So ada berapa parameter di sini? 2. Maka d2y dx squared kita ada 2 lah jawapan. Alright.